What's up, everybody? So in this question, we have to explain the difference between an odd degree function and an odd function, and we have to provide examples of each. So let's start off with the odd function. Now, an odd function, if you remember, it basically algebraically satisfies f of negative x equals negative f of x. And graphically, it is rotationally symmetrical about the origin. Another way to look at an odd function, if you remember, I mentioned this in the lecture videos, that an odd function has all odd exponents and no constants. All right, so for example, something like, let's say, x cubed. Right, so notice how there's no constants and the variable only has an odd exponent. You could also maybe even add like x here, x to the power of 1. Right? No constants and all the variables have an odd exponent, 1 and 3. Or this one can be instead, let's say, 5. All right, so those are the explanations, or those are the characteristics of an odd function. Now, an odd degree function, all that means is that the highest exponent is odd. However, unlike an odd function, it doesn't have to satisfy this algebraically. It doesn't have to be rotationally symmetrical about the origin, and it doesn't have to have all odd exponents. So for example, a function like x cubed plus x squared. That is an odd degree function. It's a cubic function, has a degree of 3, so the degree is odd. But notice how it's not an odd function, because we have this x squared here. If we tried to satisfy this, f of negative x equals negative f of x, that wouldn't work. But sometimes both of these can crisscross. So like you can have a function that has an odd degree and it's an odd function. A good example of that is like x cubed. Right, so x cubed is an odd function. It's going to satisfy this algebraically. It's going to be rotationally symmetrical about the origin. It's also an odd degree function. So you could have functions that are both of these, but sometimes you'll have, like I mentioned, an odd degree function like that, but that there is not an odd function. It's neither an odd function or an even function. It's neither. So this is an example of an odd function. This is an odd degree function. An odd degree just means that the highest exponent is odd. An odd function, all of the exponents have to be odd.